We continue looking at the units of measurement, still with objective 1 and objective 2. This is part D, the final of this portion, identifying measures. This time we're looking and considering the volume or the capacity. We're determining when to use the various units for this measure. So, if you've ever been thirsty and you're looking for something to drink out of, I'm not saying that you're a wine drinker, but was the one image I could find that demonstrated vessels that could contain liquids. So, which one would you use or choose to quench your thirst? Of course, the measurements that are given. The largest one is this is 7.5 inch champagne bucket. I think almost the size of a bucket used to mop the floor with. And even some as small as is. Well, I saw one for 2 ounces. So, anyways, yes, 2.5 ounces. Of course, one, of course, I'm sure is too much, and the other, I'm sure, is too little. But when you choose something, you're considering how much you can drink. Um, a soda can is 12 ounces. If you go to Wendy's, a biggie drink is going to be 32 ounces. You would know what type of capacity you have for your stomach. So the amount of liquid that each glass can hold is the capacity, and as mentioned, so is the stomach, but the stomach can stretch. Once these glasses are made and the volume is finite, it will not increase or decrease. When we measure liquid capacity at room temperature, the amount of liquid will remain constant. So there are certain things like butter, like room temperature, it's going to be more of a plasma, or it's not really a liquid, but it's not really hard and solid either. Water, of course, will remain in a liquid state between 0 and 100 degrees Celsius. So, when you consider gases, though, the capacity will change severely because this tank can actually be empty, but that's not really describing the capacity of holding gases. So, if you were to put gas inside of this propane tank, there will come a point at which it's no longer safe, and the containers will say, I can't hold any more gas, and it will explode. In these instances, knowing how much space inside the container is actually more appropriate. So a liquid capacity and the volume can sometimes be very different. So look at these solids. We have the cube, the cone, the pyramid, the sphere, and the cylinder. All of the space that is contained inside of these solids would be known as the volume. If you were to try and put liquids in these spaces, then you would be looking at capacity. So gas capacities would be taught at a higher level, my course, probably in college or who knows, engineering, who knows. Not in this PowerPoint. So once again, if you have a solid object, the object will have three dimensions. It will have length, it will have width, and it will have height. If it's a pool, of course, it can also have depth.